At t equal to 0.02 seconds, the shape of the graph, the shape of the rope will be green color one. At t equal to 0.08 seconds or 8 milliseconds, the shape of the rope will be red color one. Very nice question. Very easy also. It's very easy also. Okay, I'll proceed like this. Let me try in my own way. I do take help of the circle concept here again. So I t equal to 0.02 second or 2 milliseconds where the particle is here. 2 milliseconds. After 8 milliseconds, where it will be somewhere here. This will be you call let's take this as amplitude A. What can be this? This should be A by root 2. And what is A? A is equal to 1 centimeter. He didn't mention, let's assume that one. Don't write y-axis 1 meter, not possible that much of wave pulse or the transverse wave of that much of big amplitude. We don't have instrument. Is it possible for you to wave your hand for 1 meter? Okay, at least I'm giving some idea. Try to think. Can we calculate frequency with this circle? First, very important thing is we can calculate very easily. So can we predict this angle? So I'm interested in this angle first. Theta, let me take it. What is this angle? Should be pi by 4. So we say a by 2. So sine theta. No, what is the time? It was here at 2 milliseconds. It was here at 8 milliseconds. What is the time taken for it to traverse from there to there? It will be, so the point on a rope will not move in circular path, will move vertically. So this is for our convenient. It will be like this. Okay, now what is the angle? Pi by 2 plus pi by 4. Time taken will be 6 milliseconds. For 2 pi radian, what is the time period? 3 by 4. Anybody value time period?
16 milliseconds.
16 milliseconds. Then we know frequency 1 by t. Thousand 500 by 8, 250 by 4. Anybody value? 1000 by 16, no? 62.5. Okay, yeah, fine. 62.5. Okay, let's check. I think options are not there, no? Where we are. Let me do one thing. Okay, this is a by 2. 6 milliseconds. This is correct, no? Pi by 4, 3 pi by 4. 16 milliseconds. Is it correct? Check once. Okay, yeah, fine. This also. 3, 3, 2 ja 6, 2, 2, 4 ja 8, 8, 60 milliseconds, 1 by t. 60 milliseconds, 62.5, the frequency of the wave. Okay, some correction is there. Okay, there's the frequency of the wave. After getting this one, now how to get the speed of the wave? Book answer given 104. Check it once where we are doing calculation. Book answer given 104. Time taken to complete one oscillation. Is asking frequency of the wave. Okay, yeah, we are getting this much. Okay, next afterwards. This one, how to get the speed of the wave?
Sir, from velocity, if we do, we are getting 104, sir. We'll find velocity and we'll equate it to f lambda. Like that, we are getting 104.
First, you're going to calculate the velocity, no? If you calculate velocity, then you're calculating lambda. Okay, lambda we know. Okay, lambda is how much? Lambda will be 8.
Yes, sir.
Yes, lambda will be 8. If you know lambda, and we can calculate the velocity here. If you look at this particular thing, the peak was here, no? So what is the time taken for the peak to propagate? So it will cover 5 meters in that interval of time.
We are getting 2500 by 3, sir, velocity.
There should be the answer. Okay, yeah, that
Yes,
one.
sir, 2500.
So to get the velocity, what we do is we just take help of this particular data. I think I need some other color. Yeah. Okay, this is at extreme point. There's a delta x. So what is the time taken by the wave to propagate this distance delta x? So in what interval of time? I think I'm. Okay, let me do this one. The speed of the wave given by delta x by delta t. Delta x, how much you'll get? 8 minus 3. Time interval will be 8 milliseconds minus 2 milliseconds. So this will be 5 by 5000 by 6. How much will get? 2500 by 3. Okay, there's no problem with this option. Now what will happen after getting this? We know the lambda. Lambda will be 8 meter. We'll assume that one. Lambda is 8 meter. From this, what happen? We'll get the frequency. Lambda, how I can say 8 meter? So this will be, if I take the green color one, this will be the lambda. So lambda, what happen, will become 8 meter. So then F is equal to V by lambda. So 2500 by 3 by 8. How much you'll get this with this?
So 104.16.
104.16 hours. Okay, this I think may not be for a t equal to 2 milliseconds. The point is here, no? Okay, what is the problem with this one is, so it will move down. We don't know whether it will be descending or will be ascending up. What direction the wave propagating also not given. Okay, that is a problem with the data. If he says about something like, it may be here also, no? Am I right? Because we don't have any information like what is the, in what direction the wave is propagating, all that condition. The particle matlab maybe like this. We don't have information of whether the particle is moving down or moving up, because for that we don't know the direction of wave propagation. I think he has not given. So therefore, this cannot be advisable to take this one. I think circle method we can avoid, because we don't have information how the particle, whether it will just move from extreme to this particular point, or will move from upper extreme to lower extreme, then it will be here. So I just assumed blindly here, I got one answer, but I think answer is not matching. So some data information is not sufficient to think in this way. So I'm proceeding in this way here. Okay, all of you. So I think shall I take it out? So this, why answer is not matching means data not sufficient. But both ideas are needed. It's not that only this one. Particle may be here. It be moving. So either this position or this position we don't know. That's what happened. We are ending up like this here. Maybe I think if you check for this, we may get answer. Data is not sufficient. That's why answer is data is not sufficient. That's why answer is not matching. Okay, I'm making things clear. Okay, now I agree. The wave is moving along positive x-axis. I know it, but what about this particular point? It may be here or here, no? He has not mentioned whether the particle will be at a by root 2 with moving down or ascending up. We don't know. Are you getting no? Is it the motion of particle is just simple like this, or it is like this? We don't know that. Okay, got this. I just wanted to have all the ideas. See, whether we'll get answer, why answer is not matching, where we went wrong. It's not that this method is wrong. The information is not sufficient for us using this method. So therefore, I'm picking up this one. How to predict wavelength? Distance between 2 points which will have same phase. Both the particles, so like both the points on a rope are at the upper extreme. So this will become one wavelength. Okay, these are some very good numericals, huh? Where a student must have all, you should think in very different ways here. Different methods available. Take help of that and try to work out. Let me introduce to the next thing.